Hey guys, welcome back to another lesson. Today we're going to talk about our inscribed angles. And this is just how to calculate with them, discussing some of the theorems, but I'm not going to actually prove any of the theorems in this lesson. Maybe I'll come back to this and we might do some proofs with it. But just for currently right now, I just want to focus on how can we use some of the basic properties of inscribed angles. All right, so we're going to go ahead and jump right on into it. Let me bring the PowerPoint up for us so we can look at it together. Here we go. Okay, so inscribed angles. Some definitions on it. An inscribed angle is the vertex, an angle whose vertex is on a circle and the sides or chords of that circle. Now, if you remember what a chord is a segment that goes directly across the circle itself. So I'm outlining that in blue right there. Now notice these two chords do take a chunk of the circle with it, right? This arc right here. So this arc, we call it as the intercepted arc. Just an adjective to describe what the picture is showing us here, okay? So that's called the intercepted arc. Now, what about the measurement? Now remember, we did central angles where the central angle was the measurement of the arc, but in this case, it's not quite the same. Okay, the measure of an inscribed angle is actually half of the measure of its arc. Now, these other lines, it would be used for like a proof, which, like I said, for this lesson right now, we're not going to focus on a proof. So from here to here, let's say that was 100 degrees. Okay. I don't know why the one's longer. That means that angle D would actually be 50 degrees. It's going to be half its measurement. Okay, that's what an inscribed angle would be. All righty. So far, so good. Okay, so let's go ahead and try two examples out. And it's going to be these two that we're going to be talking about. So looking at the first one, notice I want to figure out what the arc is right here. Now, this is my inscribed angle. Inscribed angle, because it's on the circle. And the sides are chords that go across the circle. Now, I could have continued drawing them, but I stopped there. And this box means it's 90. So this is 90 degrees. And we just learned from the theorem that this guy right here, okay, if I take half of it, I get the inscribed angle. So what number could I have? What number could I have to get 90? And you would probably say, well, Mr. McCullough, I would just double it. And you're absolutely correct. This guy right here would be 180 degrees for us, okay? If I take half of it, I get 90. It works with a theorem, so we did this correctly. Okay? Not a bad calculation, huh? All right, let's look at the next one. Now, the intercepted arc is 80 degrees. I want to find this angle. This is my inscribed angle, okay? And the inscribed angle is half the measurement of this guy. Therefore, my angle has to be 40 degrees. That's half the measurement of this. A lot of people always look at me after this lesson like, this is easy. There's got to be a catch somewhere. And no, there isn't a catch to this at all, I promise you. Okay? So what do you think? So far, so good? Okay. Let's get back to the PowerPoint. Let's talk about congruent angles, inscribed angles. Okay? Now, you could probably, intuitively figure this part out. For two inscribed angles to be congruent, they have to share the same arc. So this arc that I'm outlining in blue, okay? If I look at both of these angles, C and D, if you trace out their side lengths, they both intercept AB. And because they both intercept AB, these two have to be the same measurement. So for instance, if this was 100 degrees, we'll use 100 again, then angle C is 50, because that's the arc, right, that it corresponds with. And this guy right here would also be 50 because it corresponds with the 100-degree arc as well. Okay, not too bad, huh? All right, now let's go ahead and try an example out with this. Very basic example, but it does the job. All right, and can I use different colors? Here we go. All right, now let me go ahead, I'm going to trace angle E for a second. So here's angle E, okay? And I want to figure out what angle F is. I don't know what that measurement is. But I outlined angle E in black, and notice it spans the entire arc DH, right? Now, let me go ahead and pink, I'm not sure how well this will show, I'm going to outline F. Okay, and if you look at that, it also outlines DH. It has the same arc. Now, F and E are both inscribed angles, and they're both half the measurement of this arc. So if that's the case, then I could say that angle F has to be 75 degrees since they have the same intercepted arc. Okay. Now, let's say you didn't know that. If you didn't know that small little property there, well, if that's 75, this must be 150 degrees, okay? And because angle F is inscribed and has that intercepted arc, this would be half of it, which would give you 75 degrees. So without even knowing the theorem, you could still figure out that measurement. All right? Pretty cool so far, huh? And a lot of times it helps to trace things out. If you have multiple angles that are inscribed, it can be a little bit tricky to see what your intercepted arc is. So just be careful with it. Sometimes it helps if you do want to color code a little bit. All right. Back to the PowerPoint. Here we go. Okay, small recall segment. Recall that inscribed polygons means that all the vertices lie on the circle for that polygon. Circumscribed means that a circle, all right, has all the vertices of that polygon contained. It's pretty much you're just changing perspectives on this. And we talked about that in the very first lesson of circles. We're going to use that knowledge for the next theorem. So an inscribed right triangle theorem, all right? And I think this is pretty intuitive as well. Let's take a look at this triangle. You see how this triangle has the diameter involved right here? And if that's the case, this arc has to be 180 degrees. The diameter is half a circle. Half a circle is 180. We also call that a semicircle. Angle B is the inscribed angle, okay? So that means that angle B has to be 90 degrees. It's half the measure of this guy. So the inscribed right triangle theorem is stating that, okay? As long as the diameter is part of the triangle, then that must be a 90-degree angle, okay? And that's because it's a semicircle if it is part of it, all right? Okay. There we go. All right, let's try another example. Stop just a little bit. Okay. All right, now I have a triangle, and notice the diameter is part of the triangle. So using that theorem, I could say that the inscribed angle, which is across from the diameter, has to be 90. And if you weren't sure of that, go back to inscribed angles. From here to here, that's 180 degrees, right? That's half a circle. This has to be double this guy. So that has to be 90 degrees. Okay, just basic properties of an inscribed angle. So once again, if you weren't sure of that, you can still get to that conclusion. Now, because I have a triangle, I know all the angles add up to 180 degrees. Now, if this is 90, we could actually cut the calculations down a little bit. I know that these two angles right here have to add up to 90, right? There's only 90 degrees left. 4x plus 2 plus 9x minus 3 equals 90. They have to add up to 90. Now, you could put plus 90 equals 180 if you want to do all three angles. I'm just trying to cut down the calculation a little bit. Okay, and I guess I didn't say this, but we are solving for x, by the way. We'll plug one of the numbers back in just to confirm some measurements, but we're solving for x, if you haven't picked that up. 4 and 9 gives me 13x. 2 and negative 3 gives me negative 1 equals 90. Okay. So we get 13x, okay, equals what, 91 for that guy? Okay. And then for my last step, I'm going to go ahead and divide both sides by 13. And we get x to be 7 for that guy. Now, let's say I want to figure out the measurement of angle H and the measurement of F. Oops, sorry, that's written incorrectly. Just to see if I'm correct. And it's always good to check your work, right? Okay, angle H. 9 times 7 is 63, minus 3 is 60. Okay, so we got that, which means this better be 30, right? Because I have to add it to be 90. 4 times 7 is 28, plus 2 is 30. Yeah, it works. 180 degrees in a triangle, everything matches up perfectly. Okay, that's the right triangle inscribed theorem. Inscribed right triangle theorem. Sorry, took that back. Everything so far so good. Okay. One more. All right, let's go back to the PowerPoint real quick. Now, what if we did a just normal polygon? Let's say a quadrilateral. All right, so the inscribed quadrilateral theorem. So what is this entailing? Let me get the pencil tool out and I'll circle some things for you. All right, so taking a look. Angle D is directly across angle F. And realize that they're both inscribed angles. It's very important, okay? Angle D and angle F are called opposite angles because they're across from each other. And their relationship is they are supplementary. They add up to be 180 degrees, which means that angle E and G are the other opposite angles, and their measurements add up to 180 degrees. Okay, so that's what this theorem is stating for us right here. Ooh, sorry. Try it again. Underline it this way. That's what the inscribed quadrilateral theorem is stating, okay? If they're opposite angles and they're inscribed, they add up to be 180 degrees, all right? Very basic property. Okay, so let's go ahead and try an example out to finish this up, okay? And move this over. Go. Okay. I have this quadrilateral that's inscribed. And what I'm going to do is just label some things here. So this angle and this angle are opposite angles. And according to the theorem, they add up to 180. So 80 plus angle Z adds up to 180, okay? Which means Z must be 100 degrees for that to happen. So that's going to be 100 degrees for us. Use a different color. I think pink shows up okay on the recording. Let's try purple. Okay, so the two angles I circled are opposite angles. They're the other set that add up to 180. So y plus 120 equals 180. For that to work, y must be 60 degrees. So then angle y would be 60 degrees for that guy. Okay. And that's it. Okay. The theorems themselves are pretty basic and straightforward. The calculations for this, as you can see, it's really not that bad. It just comes down to, do you know those properties? Okay. And like I said, maybe in the future, I'll upload a video of me showing like a proof as to how this works. But for right now, we're just going to call it quits right there. It's the end of the school year. At least at the time of this video's recording, it is the end of the school year. And I think we're all kind of burned out with the pandemic and everything. So we're just going to keep it very straightforward. So I really hope you guys are doing well. Congratulations on making it through the year. And that's it. So unless in the future, I'll see you guys, or else just see you online in the next lesson video. All right, take care.